recording. Okay, so we're continuing with science 6.04. If you haven't finished your rocket, it's okay because you're going to have a little time to finish your rocket while we're reading through the rest of the lesson and learning about the experiment that we're going to do today. So you should get out your notebook if you haven't started yet, and some scissors and some tape and a straw. You need a plastic straw and a pencil, and then you'll be in good shape. Yesterday we started this and we went to the lesson on page 6.04. I'm kind of a little further into it here. And it's got 17 pages, but you guys have 4 days to do this lesson. So page 1 just talked about force and motion. Page 2 talked about strong and weak forces. And page 3 talked about changing motion. But page 4 had the experiment on it. So it says, practice like a scientist, make a rocket. Follow along with the procedures. This gives you the directions. This is the rocket template that you should be able to find in your notebook. We all found it eventually. So you're going to cut out this rectangular piece, and then you're going to wrap it around a pencil. So you need to find a pencil and some tape. And one thing you want to make sure is when you tape it around long ways around the pencil, that you're sealing the whole seam with some tape so that the air won't blow out of it. And then you take and cut out the fins, and you're going to attach them to the top and the bottom of the rocket, like you're making a fin sandwich. So one to each side with tape across the top and across the bottom. And then you are going to fold them so it comes out looking like, do they have the directions? No. Well, they don't have it there, but here they talked about the steps. So step 1, you wrap it around the pencil and tape it. I don't know why they have blue paper, but if you don't have the paper, you can use any paper. Then you carefully cut out the fins and tape them on.
It's not in the notebook.
It is in the notebook. I've had 3 kids say that, and when they look on the next page, you'll find it. So it is in the notebook. It's 6.04. Look past the 6.04.
I've looked on the other pages.
I know. Just look a little more carefully, okay? And then page 4, you're going to take, this is the part you need to do, Christian. You're going to take your fingers and kind of squeeze it around the tip of the pencil and then tape the tip to make a cone tip. Yeah. So you want to get it sealed so that the air doesn't come out of the tip. So that's kind of the tricky part. And then you take the pencil out and you put a straw in, and that's your rocket. So it's like that with the tip nice and sealed up and your straw stuck in the bottom, your pencil out. And you guys can keep working on that while I read the next few pages of the lesson. But hopefully you'll get your rocket done by the time we get to the experiment. All right, it's time to show how much you've learned about forces and their effect on the motion of objects. Test your skills in this new activity. How does changing the force applied to an object change the motion of the object? The stronger the force applied, the smaller the change. Thumbs up or thumbs down? The smaller the force, the stronger the force, the smaller the change. Nobody's listening. I'm watching for thumbs up or thumbs down. What do you think? The smaller the force, the greater the change. Changing the force doesn't change the motion, or the stronger the force, the greater the change. It's kind of a no-brainer, right? It's the last one. Submit. Great work. The greater the force applied to an object, the greater the change in motion on it. Give the next question a try. It's time. Let's see. Brent is throwing a baseball. He's only throwing it with a little force to pass it to his friend. If his friend moves much further away, what should Brent do to make sure the ball reaches his friend? He should apply less force. He should throw the ball closer to the ground. He should keep throwing it the same, or he should apply more force.
Apply more force.
More force. Yeah. Great work. He needs to apply more force to get it there. And the last question. After my exploration, I recognized the arrow down. Oh, I recognized that the what applied the greater the force, applied to an object, the greater the force to an object, the greater, the stronger, the change in the motion of the object. Okay, silly. That's a little bit silly. Oh no, it took me to some weird quiz. I don't know why. Let me go back into the subject. It's weird. I don't know why it jumped that suddenly. I must have clicked the wrong next. Did I click the bottom next? Probably. Okay, I think we're on page 7. All right, practice like a scientist. Print the rocket activity sheet and follow part 2 of the procedure. Follow along with the 2 adults using the slider below. With the help of an adult, place a piece of tape on the wall. I'm not going to use tape. I'm going to use a measuring device because then I don't have to worry about it. So I'm going to grab my rocket and I'm going to move to a spot in the house. I happen to have a meter stick. So I'm going to move that over here to the wall and just set it on the wall. Let's see. Oh, I put it up upside down. That's probably not brilliant. I'm going to turn on the light out here. All right. It says to put a piece of tape on the wall. That's just so you can mark how high your object went. You can use tape if you want. Then this next step is kind of funny. Step 2, lie down next to the tape and mark a spot on the tape where the straw rocket will sit in your mouth. I don't know if you really have to mark that. In my case, I think what I'm going to do actually is I can put this up on the edge so it's a little bit higher. What they're thinking is you have to subtract the part that is in your mouth. So here I am. Can you see me with my rocket? Here I am lying on the floor with my rocket like this. And what we're going to do is we're going to blow and see how high it'll go. So they want you to mark how high this is sitting in my mouth to start with, which I think is probably, it's 50 centimeters. Wow. Okay, here we go. Now I don't have somebody to help me. Maybe you do. But the next step, let's see. Have an adult help you mark every 25 centimeters on the tape up for 400 centimeters or higher. I suppose that's good practice because you're marking centimeters. Let me grab a piece of tape. Got some blue tape in here.
Why don't you just lay the measuring tape on the ground and then make it go up?
I'm just gonna
then lock it.
I'm gonna just mark the centimeters using Post-its. So here's 50. 50 plus 25 is 75, right? I put 75 right at the bottom of it. 50's at the bottom, 75's at the bottom. 25 more would be 100. That's 100 centimeters is 1 meter. Oh wait, I need to make it at the bottom. Great. You think it's gonna get this high? Okay, I need 25 more centimeters. So this is 125. Woo. And then 25 more would be 150. And 25 more would be 175. I don't think it's going to go that high because my rocket isn't doing that great. So the bottom one is going to be 0 because that's where it's starting. Now, I'm going to scoot this back so you guys can see how high it goes. I don't know if you can tell how high it's going. Here we go. Now I should have somebody here watching. I don't want it to be too stuck on my straw. So like this, and here we go. I think here, don't you think? I think it only went up 25 centimeters. Okay, I got to try again. Could you guys see it? Or not really?
Yeah, it barely went up.
Oh, I got to stop my share for a second so you can see it better. Yeah, it didn't go very high, but part of that is because my rocket was not made properly. And then my straw is just a piece of paper that I wrapped some tape around. So all of it is not perfect. Here we go again. Let's try again. Okay. 1. Blast off. Ready? You guys count down from 5. 5.
4, 3, 2, 1, blast off!
My rocket is a little bit lame. I wonder if I put it more onto the...
Okay, we'll do like an actual countdown, like this is Mission Control, ready.
Oh, that was a good one. I think that one made it up to here. So
Yep.
That's 25, 50, 75 centimeters. That's pretty good. How are you guys doing? Are you getting a spot set up to try and test your rocket?
My
I'm
camera.
still building my rocket.
Okay, let me see. I'm going to remove my spotlight. I want to go back to my share and let's see what it said to do next. So here it is. It said, have an adult help you mark. And then it said, lie on the ground next to the 0 mark on your tape. Have somebody watch while you shoot your rocket into the air. Then launch your rocket 2 more times using a weak force. Try using the same force each time. So mine only went about 25 centimeters with the weak force. Then I launched it again, but I used a strong force. And actually, I put it on the straw further. Remember to record the distance. And that time it went 75. Let me see if I can make it go 75 one more time. Here we go. My last experiment. I'll load it up. Here we go, guys. Give me a countdown from 5.
10, 9, 8, 7, 6, 5, 4, 3, 2, click, we'll take off.
Oh, yeah. That one went way up. All right. I think that one went 25, 50, 75, 100.
100?
Now I've got 50, 50, and 100. So you need to get 3 times, do it with a weak force. And
Hey, Miss Laws, can I like wrap the pencil around the the paper around the pencil and then take out the pencil and see how high it goes?
Yeah. I mean, that's how they tell you to do it, right? But let's
No, they tell you to keep the pencil inside it.
No, you're not supposed to keep the pencil inside. You have to take the pencil out. The pencil is just there until you make the tip and then you're done. So let's have a look here. So in this activity, you build your own straw rocket and explore different forces that change the motion of the rocket. I'm going to download this so we can type on it. I'll save it on my desktop and then I'm going to open it up from my desktop. Desktop. Make a rocket. All right, here we go. Now we're going to work on this. So if I were filling this out, I would put my name here, right there. Ms. Laws. And remember, you have till next Tuesday to get this done. Make a rocket. In this activity, you build your own. How can I change the motion of my rocket using different force? What do you think will happen if more force is applied to the rocket? Write your answer in a complete sentence. So a hypothesis is you need to say what happens. And if I were you, I would write it using the words in the question. So yes, Vivi? I don't hear you. Uh-oh. I don't know what's going on. Vivi, are you there?
Oh, sorry, I didn't hear you.
Oh, okay. I called on you, but I didn't hear your voice. What's your question?
Oh. Is this a quiz or
No.
option? I want to know, is that whole thing option or that people?
Well, actually, I haven't looked, Vivi. Let me look and see. I thought this was the assignment, but I could be wrong about that. Let me go to the last page. Did you look on the last page?
Yeah, it says that
Yeah.
6.2 forces in motion and that it's a quiz.
So here's the thing on that question about whether things are optional. I mean, ideally in Florida Virtual, if you have time, you try to do all the activities they ask you to do, but this is not turned in or graded. Does that answer your question?
Yes.
All right, so back to the worksheet. I don't know if this is my copy. It's not. Okay, I got to find my copy again because I can't edit this one. Here we go. Here's my copy. All right, so a hypothesis you can write before you do an experiment. You always want to think about, like, what is it I'm really trying to figure out in this experiment? So, and what do I think will happen? So you make an educated guess. And I would like you guys to try to use the words in the question to answer the question. So if the question says, how can I change the motion of a rocket using different force? And what do I think will happen if more force is applied to the rocket? I want to say if more force, oops, I'm in caps. If more force is applied to the rocket. So this is called using the question words in the answer. It's a really great thing to do whenever you're filling out a worksheet. You want to take the question itself and use it to answer it. If more force is applied to the rocket, come on, those laws, don't be grabby there. I think, and this is the hard part, right? Because you have to think about it. What do I think is going to happen? Well, I think it will go higher. I think the rocket will move more. I actually think in my case, it was kind of interesting because it had a lot to do with the seal on the rocket. So that comes down to more force. If it's completely sealed and the air has nowhere to go, then that is more force. But in my case, I didn't do a very good job of building the rocket so that it was airtight. You probably don't want to hire me as a rocket scientist. So I'm going to actually say a little bit more in mine about, I think it will have more force the more airtight it is. Because I think that was a big problem with my rocket when I built it. You might not have the same hypothesis. Your hypothesis might be a little bit different. But I noticed when I sealed that, the straw in there, it seemed to make it go higher. It wasn't that I was blowing harder. It's just that it had less distance to travel. The air wasn't escaping the same. So the variable it's an important scientific word about the thing that you're testing. In this case, we're testing how much force is applied to the rocket. And it's not very good science of me to make my rocket differently than how you guys made your rocket. We should have made them all exactly the same with the same amount of tape and all of that, but it's hard to do that when we're all in different households. But here are the materials you need. And then it says to make it, these are the directions. Part 2, put the tape on and do the experiment. And here's your observation chart where you put in your trials. So on my first one, I think it only went about 25 centimeters. So let's put that in. And I should have had my chart out. It's kind of hard when you're doing these things by yourself, but you want to fill it in as you go.
My rocket fell behind my bed.
Uh-oh, better get it out. My second one, it also went about 25 centimeters. I didn't have someone helping me watch it, but if they had been helping me watch it, they would have seen it go about 25 centimeters. And my third one, I think it went a little bit higher, but maybe like 30. Those were my weak force. And I was doing it kind of fast. You guys want to do this slowly and carefully. If we were in class, I would help you do this really slowly. With the stronger force, though, it went on the first one, it went 50 centimeters. Oops, not 5, 50. I don't know why my pen got bigger. And on my second trial, it went 75 centimeters. And on my third trial, it went 100 centimeters. So I probably was using more force. Another thing about science is probably if you were doing this really scientifically, you would want to have something other than your breath to blow on it because it's hard to make your breath be exactly the same each time, isn't it? Graph your results using the blank graph below. Oh, good. This has graphing practice. So here I want to put trial 1 and it went 25. So I'm going to put a little chart here. Trial 2, it went, where did it go? Trial 2, 25. And then trial 3, 30. So that would be, let's see, if this is 25 to 50, there are 5 increments in there. So 30 would just be just above. Okay, and I can draw a line between them or I can just put them on like that. Trial 1 with more strength was 50. Boy, I wonder if anybody's going to get theirs to go up here to 300 centimeters. That'd be amazing. And then 75 in trial 2. And then in trial 3, 100. Okay, so I could draw a line between these and it would be a line graph. I could make bars and it would be a bar graph. I think right now I'm just going to leave it as a dot graph. All right. Oh, second rocket. Oh, you know what? I didn't make a second rocket. Did they tell us to make a second rocket?
And we only got one paper.
But there was only one template.
Well, let's see what it says here. Maybe this is where if you notice things wrong with your rocket, they're challenging you to make another and see if you can make it work better. So let's see here. Here's the rocket 2 more times using weak force. Try to use the same force. Launch your rocket 3 more times. This time use a strong force. Once your observation chart is complete, think about how you can design a new rocket. Here it is, part 3. Oh, I love this part because this is part of the design process, right? If you were a person designing something, you would design a prototype, which was our first rocket. Then you would test it. You would find out what you would change. And I've already found several things I'd like to change about my rocket. They said you could choose to change how long it is, the materials you use, the size of the fins, the number of fins, the shape of the cone tip. Build a new rocket, test it, and see if it works better. And then use the second chart to record your data. So I'm going to challenge you guys to go ahead and try and do that. I'm going to be working on mine here, and you can work on yours at home. The last part of this worksheet says conclusions. In the space provided, explain how you changed the motion of your rocket. How did you get your rocket to travel a further distance? So here they want you to explain. So for example, I'll explain what I'm planning on changing. I decided to make sure my rocket was airtight. Oops. Okay. I thought that the leaking air was stopping me from getting as strong a force as I wanted. And here you can, again, my hypothesis was that if the air didn't have anywhere to go, it would push the rocket higher. So I'm going to make another rocket, and this time I'm going to be careful that I don't have leaks all over the place, so that when I blow on the rocket, it'll go up instead of the air just leaking out all over the place. And then I'm going to come in here and I'm going to write whether or not it worked. Okay, so this is how you fill out a scientific experiment form. Doing it carefully, controlling your variables, building it, testing it, and then designing, redesigning, and coming up with a better idea. All right, questions, Kainoa?
Actually, I need help with the fin part.